Greetings, I'm Kirill Miedviediev, student at National University Zaporizhzhia Polytechnic, and I am here to discuss the development of modified genetic method for automatic university scheduling. Thank you for your attention. Effective time and resource management is crucial for success in higher education. For students, balancing studies with the work, sports, and social life is a key. Teachers benefit from an optimal class schedule to enhance productivity. Automatic scheduling is essential due to the numerous constraints. The scheduling problem and P-complete issue is addressed using meta-heuristic algorithm. This paper introduced a modified genetic algorithm for efficient university scheduling. The purpose of research is to develop a mathematical model for solving the task of creating an optimal schedule of classes for higher educational institutions. To achieve the goal of the research, it was necessary to solve the following task: to develop an adaptive classic genetic algorithm for drawing up an optimal class schedule, to develop a modified method of the classical genetic algorithm, to present an experimental study of proposed genetic methods. The task of creating a schedule is to create an optimal schedule of classes taking into account various restrictions and requirements. This issue belongs to the class of NP-complete problems because its combinatorial optimization problem is which the number of solutions increases with the size of in the input data, constraints, and parameters. The objective function for scheduling problem defines the main optimization criteria, which include minimizing the number of windows between classes to reduce the downtime of teachers and students, uniform distribution of the load during the week to increase work efficiency, minimizing of conflict and overlaps of classes, which involves avoiding overlap between classes when join groups, teachers, or classrooms, taking into account proposals regarding the schedule to meet the needs of students and teachers. Planning training session is a complex task and conventional scheduling method falls short. Employing high-risk methods like genetic algorithm, while not ensuring the optimal solution, proves effective in searching for optimal options. After analyzing various methods, the genetic algorithm emerged as the most suitable for creating an optimal class schedule. Consequently, an adaptive and modified genetic algorithm was developed for this purpose. The scheduling algorithm aims to minimize the objective function expressed as minimize the function f of s, where s is a class schedule, the function f of s is the objective function. The quality of algorithm result is assessed using the objective function indicating the number of violations of specific restriction. An evolutionary genetic method optimizes the objective function by gradually approaching the optimal schedule through key steps. Initialization, input data and algorithm parameters, creating the initial population, calculation, individual adaptability, crossing individuals, mutating individuals in the population, evaluating the suitability of obtained individuals, selection, repeated steps until the stop criteria is met. Criteria for stopping the algorithm: if the maximum number of iterations is reached, if the schedule is found, the fitness value of which is equal to 0. The island model of the net genetic algorithm is similar to the classical genetic algorithm, but involves the creation of separate groups of the population that function in parallel and can interact by enhancing individuals. The island model of the genetic algorithm includes such operation as the initialization of individuals island with different parameters and possibility of migration of individuals between this island. The algorithm uses modified random initialization operator. Here how it works: we randomly pick a day of the week, select a class, and then find a suitable time for it. If it's the third class on the day, we insert it randomly. If there is already a class, we choose a number in a way that minimizes violation of restrictions. This results in schedule without class overlaps and fewer gaps. Implementing this initialization method significantly accelerates the genetic algorithm performance. As the initial data for system was sourced from semester assignment information provided by software department, This document encompasses the subject links, groups, attendance of subjects, lesson names, and recommendations for required classrooms. The input data for the algorithm included a list of classes, each featuring teachers, one or more groups, subjects, class time, and meeting frequency, a recommended schedule for classes, the number of school days, the maximum number of classes per day, a list of classrooms. After analyzing the genetic algorithm launches, let's discuss the optimal convergence rates for the GA parameters. Mutation probability 0.2, mutation type single gen mutation, crossover probability 0.6, allotype value 0.2, sampling type roulette, crossover type single gen crossover. Now turn our attention to the island GA model launches. We find the most efficient convergence rates for the island model parameters. Number of island 6, parameter divergence step 7, number of iterations for migration 10, number of individuals for migration 0.1. On average, the running time of island model with using modified initialization method is 2335.027 seconds, while with using random initialization it's 1313.531 seconds. Remarkably, this island GA model is an average 1.8 times faster when applying the modified initialization method. The enhancement contributes to improve algorithm performance, saving valuable time and resources in problem solving. This slide displays a table showcasing algorithm runs with the optimal parameters. A modified genetic method with an enhanced initialization operator leveraging prior information significantly reduced search time. The modified island model of this genetic method distinguishes itself by using modified initialization operator, reducing classical genetic algorithm running time by 40.9%. The island model's running time with the modified initialization operator is 1.8 times faster than the classical method, leading to substantial time saving. In experimental studies, the island model of the genetic algorithm proved more efficient, exhibiting a 41.3% reduction in execution time and on average an achievement superior fitness fitting function result, making it more effective solution for scheduling classes.